Hi everyone, welcome to the Android App Security Fundamentals workshop. So this workshop is going to be given by Nikhil Kulkarni, and this is intended for students, professionals who are actually interested to make career in mobile app penetration testing domain. So, and it also involves decompiling real-time analysis and testing Android applications from security point of view. This workshop covers the fundamentals of Android app security with real-time testing of Android applications and some of OWASP Mobile Top-10 security issues, like insecure login, unintended data leakage, insecure communication, insufficient cryptography, insecure authentication, and poor code quality. Now, this session has been given as part of the OWASP Bangalore, and Nikhil is one of the chapter leaders for Null Bangalore, and I would like him to introduce himself more and talk about uh, his profile and what he's going to be sharing more.
Okay.
Over to you.
Okay. Thank you, Vandana. Hey, everyone. Good evening to OWASP Bangalore, and a good day to all the folks joining us from different parts of the world. So, as she introduced, I'm Nikhil Kulkarni. So, I'm currently leading the security team at IGS India. It's a startup here in India, and my main interests have been more of into application security, and then I've moved on to mobile security, and now into cloud security. I've presented my papers at various different conferences like Nuit du Hack in Paris, OWASP AppSec, then a bunch of other conferences like KubeCon, then Hackfest Canada, and bunch of others. I've also been an active bug bounty hunter. I've been listed in a bunch of Hall of Fames like Microsoft, Apple, Adobe, and a couple of other companies as well. So today we're mainly going to be looking into the Android application security fundamentals. We'll look into how to reverse engineer a mobile application. What are all the different security aspects that needs to be put in picture when it comes to mobile application security, and how these vulnerabilities are usually exploited. So I think we could get started now. I think let me just share my screen now. Okay, so here we go. So let me just start with the presentation. I hope it's not going to be boring for you guys. Okay. So just a small disclaimer about this presentation. This is intended only for the educational purposes, and I am nowhere liable for any damages done after you guys learn whatever anything from this presentation. And feel free to practice whatever has been learned from this presentation. And please do not try to attack anyone else's application without their permission. Okay, so this is just a small disclaimer that I wanted to convey from my side. So let's get started. So what is the agenda for today? So we're going to be looking into the basic things such as the introduction to Android, the complete Android architecture, and then we move on to the Android security architecture, then the Android permission model, and this concept called sandboxing, which is quite widely used when it comes to mobile application architectures. Then setting up the mobile pen test environment, like what are all the different set of tools that are needed, how do we what are the different set of flags that needs to be used in the CLI commands and all of that. Then Android application architecture. Then how do we reverse engineer a mobile application, which is an APK file, either be it an APK file or a .dex file. We'll look into that. Then we'll also look into bypassing Android permissions to some extent. Though this is a really big topic and a vast topic that we could probably cover in another training session or something. Then we go on to the dynamic and static analysis of an application. Then in under this we would be looking at bunch of things like insecure data storage. There are different varieties of insecure data storage on a mobile application, and how a poor code quality would basically affect a mobile application's security. Then we'll also look into the forms such as the vulnerabilities forms such as insecure communication, insecure authentication, and insufficient cryptography, and bunch of them. So this is the agenda for today's workshop. I hope you guys are going to be enjoying it and learning some new stuff. Okay, so let's get started with the basics of Android. I know this is a boring stuff. This is one of the boring slides I can say, wherein we talk about the history of Android. Android basically was founded. Android Inc. was basically founded in Palo Alto, California, United States, somewhere in the year 2003, October, by this guy named Andy Rubins and Rich Miner and bunch of other folks as well. So this started out as a company, and later on was bought over by Google and a bunch of companies that came in as part of the Open Handset Alliance, which basically were able to form this whole Android as an operating system. Okay, so Android, when we could talk about it, it's basically an open source software platform and an operating system for mobile devices, and it is mainly based on the Linux kernel. So we'll go much deeper into how it is how it is completely based on the Linux kernel in the coming slides. And again, it is developed by Google and later the Open Handset Alliance. We'll look more into the Open Handset Alliance in couple of in bunch of other slides. So then it allows writing managed code in the Java language. Then Android has its own virtual machine that's called the DVM, which stands for Dalvik Virtual Machines, which are usually used to execute something called as Dalvik executables. So these Dalvik executables are very specific to Android, and these usually are run under the DVM environment. So, as we spoke about, Google purchased the initial developer of the software, Android Incorporated, in the year 2005. So, talking about Open Handset Alliance is an alliance between a bunch of different companies that came together, just to sort of, take Android as an operating system for mobile devices. Okay, so they devoted to advancing open standards for mobile devices, and their main agenda is to make sure that the mobile technology or the mobile operating system takes a new shape altogether. So now let's look into the Android architecture. So talking about the Android architecture, we'll be looking into a bunch of things like what are the Android framework, the Linux kernels, the libraries, Android runtime, application framework, application. So all of these basically form part of the Android architecture. I think the better way would be to sort of give you a pictorial representation of this, of how the Android architecture actually looks. So Android versions, I'm pretty sure you guys are quite familiar with. It basically goes on with in an alphabetical manner. So we have donut, eclair, froyo, gingerbread, honeycomb, and bunch of others. So the current, the very recent version that we would have seen would be the Nougat, then the Oreo, then the Android P. So yeah, so Android keeps changing a lot of things, and they keep upgrading a bunch of different things in their operating system, and henceforth the new upgrade is given a new name. Okay, so this is the Android architecture. So if we could see, there are four main components here, starting off with the Linux kernel, on top of which there is libraries, then there is Android runtime, then the application framework, and the applications. Okay, finally. So these Linux kernel, these are pretty much like the drivers. We have display driver, then we have camera driver for, which is the driver for the mobile camera. Then we have a different driver for the flash memory. Then there is one for power management, audio driver, then Wi-Fi driver, and keypad driver. So these are the softwares that would basically help, to take care of your hardware parts, components in your mobile devices. So talking about the libraries, so there are a bunch of different sort of libraries that are specific to different functionalities of in a mobile environment. So let's for example, if we consider SQLite, SQLite is mainly related to the databases in the mobile architecture. Okay, so in the similar way, there is OpenGL for the the UI and all of that. Then there is SSL, that's part of the security. Then there are a bunch of other different sort of libraries as well. So we'll come back to the Android runtime in a couple of minutes. But before that, let's understand about the application framework. So application frameworks are nothing but like your libraries, which allow you to do a certain functionality in a mobile application, using a mobile application. So something like if you want to make a call or probably send an SMS, you would be using something like telephony manager. In the same way, if you're using your maps, then you would probably be using location manager in your application. So these are a bunch of functionalities similar to let's say if if you're quite familiar with the C programming, the hash include stdio.h, which you're basically including that header. It's kind of similar to what the application frameworks are doing. So if your application needs to have the ability to sort of send and receive SMSs, then you would want a telephony manager being part of your application. So on top of that, we have the applications, wherein the contacts is a different application, phone is a different application again, so is the browser. So there is a different set of these are the different applications that would utilize these application frameworks to sort of perform different functions. Okay, so coming back to the Android runtime, so we have something called as Dalvik virtual machine, which is very specific to Android here. So in Android applications, so the Android applications come with the extension of .apk. And when we say .apk, and when the applications are installed on a mobile device, so for them to run under the Dalvik virtual machine, they would be in the format of .dex files, which is Dalvik executables. Okay, so the core libraries part basically forms bunch of Java based libraries. Then under the Dalvik virtual machine, every Dalvik virtual machine is basically a sandbox. So which means that every single application on your Android device runs in a separate sandboxed environment. So which means that the application resources, something that's got to be like the databases, or let's say any sort of files that are specific to one particular application, cannot be accessed by any other applications built by a different developer. So that's one of the amazing part of the Dalvik virtual machine. Okay, so let's move ahead with the different layers. Okay, so as we discussed, these are different set of layers of the Android architecture, starting off with Linux kernel, the libraries, the Android runtime with the application framework. Then you have finally the application. Okay, so I hope I made I mean I was able to sort of get you through the Android architecture part. Now this is kind of very important for us to sort of go ahead and later on understand the security implications and all of that. So as we spoke about the DVMs and the Dalvik executables, so to execute the application in the Dalvik virtual machine, the Java file is usually compiled and the .class files get created, right? So the .class files cannot be executed in the DVM, therefore it needs to be converted to a .dex files. So since DVM can execute only dex files, so we use something called dxtool, wherein the .class file gets converted to the .dex files. Okay, so again, so the one of the things that the dx tool would do is to remove the redundant information from the .class file. It removes usually more than 50% redundant information from the .class files. Okay, so let's move ahead with the Android permission model. So how the security at a basic level is taken care in the Android application. So as we all know, as most of us would have used Android device at some point of time. So the security features at a fundamental level are usually provided through a permission mechanism in Android application. Okay, so whenever you install your Android application on your Android device, the application would ask you for a bunch of different set of permissions. Only when you grant them, they would sort of utilize. Let's say if an application wants to utilize, wants to access your photos or your media, then it would pop up, a thing saying that, would you want to allow the application to utilize your gallery and your photos or your media files and all of that. So once you allow it, it would go ahead and access them, or it would use them. Or once you deny them, deny it, if it would not, go to fetch any. It doesn't go and fetch those, resources. So we have a different set of Android permissions. If we can see here, there is one for calling, there is one for messaging, there is location based permission, there is contacts, content, alarm, account, network. There are a bunch of different permissions in Android, per se. Okay, so the permission level in Android basically is, again, divided into multiple levels. One would be the normal permission, such as something like vibration for an alarm. For Then there is something called dangerous. Then there is signature. Then there is signature or system. So more about this, we would sort of encounter these when we actually go ahead and look into the permission model during the demo time. So let's now look into the Android security model. Okay. So the Android security model provides security for the application and the user at multiple different levels. Okay, starting at the operating system level, which is at the kernel level. There is a different way, how the security is handled at the kernel level. Then, as we spoke about the application sandboxing, wherein each application basically runs in its own sandbox model. Okay. In the similar way, there is something called as secure IPC, which is inter-process communication, wherein there are a bunch of different processes that are running and different applications that are running, and the communication between them, the way that works, is also a part of. There's also a secure IPC that needs to happen. Then there is something called application signing, just to prove that who is the developer of that particular application, or who's the one, which is the organization that built this application. So that's one part of it. Then there is something called permissions. Permissions is what we just looked at. Then there is also called as something called as Google bouncers. So Google bouncers, the mechanism is usually made use on the Google Play Store and not on the actual your Android device. Okay, so we'll talk about Google bouncers in the next upcoming slides. So considering the security at the operating system level. So the two major ways that the security is basically implemented would be the enforcing of the permissions and the unique UUID for each applications. So when I say enforcing of the permissions, it basically means that okay, so these two are kind of related to each other. So every single mobile application on your phone that is being installed gets a very unique user ID. Okay, so which means that whatever processes that particular application is running, it comes in as part of the part that is specific to that particular application. You could be able to sort of figure out that which process was run by which application, and the access to the resources of those of that particular application is again enforced with respect to a permission. Okay, so we'll look into that as we go into the demo side of it. So considering the exercise, okay, so if you guys are able to have your command prompt with you at this point of time, you could probably do this. Okay, else not, if you could probably go back and later do this. I'm anyways sharing this presentation with the OWASP Bangalore so that they could sort of share it. And there are a bunch of other different applications that I would be sharing, which are like test applications that you guys could go on and install it on your emulators or on your on your Android devices, and probably run it and try to figure out what security flaws that those applications would have. Okay, so let's get started. So I'm going to be running a, an emulator called Genymotion. So let's start this. So I'll be giving you guys a much more detailed, introduction to Genymotion in a bunch of in a couple of slides, and yeah, more on the tool set that we'll be needing. The complete setting up of the pen testing environment will also be taken care. Let me just keep this on this side. Open up a terminal. Keep it on this side. Okay. So we are going to be using also this command called adb. Okay, so what does our exercise say here? Let me just open that up here. Okay, so open up command prompt, get an adb shell onto the device that is connected to your system. Okay, then check the uid of different applications that are running. Okay, so let's do that. So before we get an ADB shell into it, let me just give you a small introduction about what is an ADB. What does it do? So ADB is basically Android debug bridge. It helps us to basically connect from our host machine into our Android devices that is connected to the system. Okay, basically sort of also gives us a reverse shell onto the system. Okay, so before that, the command line for ADB is fairly simple. So there are a bunch of commands that we would be utilizing. So let's get started with ADB space devices. This would basically list all the devices that are currently connected to your system. Okay, since I don't have a physical device that is connected to my system, I'm using an emulator. And this emulator, again, because it's connected, it is showing up here. This is the IP address, and this is the device. Okay, so we could let's get a shell into this device, and we are in the device at this point of time. So the command that we need to type is ps. Okay, so ps to just check what are all the different processes that are running. Okay, so we can see here that u0 underscore a61 or u0 underscore a5 or u0 underscore a67 and bunch of other different user IDs that are being shown here. And there's also root user that's being shown. Okay, so these are basically the user IDs that's been given. Okay, you can see here, this is com.twitter.android. This is an application. com.android.vending, com.android.email. So these are different bunch of applications that are currently running on your device. Okay, so that's about the different user names or the user IDs that are given to every single application that is currently running on your device. Okay, so with that, let's move on and see what else we have. Okay, so as we spoke about the application sandboxing of Android in the Android environment. Okay, so each of the application runs in its own sandbox. So when we say sandboxed is basically an isolated environment wherein anything that happens with respect to that particular application will not affect any other application that is running on that particular on in that environment. Okay, so as I said, one application cannot access the data of other application, but there are certain conditions that apply here, which means that this is only true if your device is not rooted. Okay, if your device is rooted, then it's a different story. because you have root permissions. When you root your device, you basically the applications get to look at get to access the resource or the data of any other applications. So we'll look more into that in the demo part. So slash data is the directory where you will see all the application data to be present. So now that we have already got an ADB shell into the device, now we could go to this particular location, which is slash data, and we'll get to see different set of directories which specific to different applications, inside which you will see different set of resources that come in with these applications. So let's do a small exercise here. This is going to be very interesting. So it says that open the messaging applications on your emulator or your device, send an SMS to any number. So once sent, we get an ADB shell onto the device and navigate to the SMS application, and we'll get into this particular directory, which is slash data and com.android.providers.telephony. Get into the databases and see how these things really work. So the reason why we are trying to do this is, in the normal scenario this should not be happening, but since our device, which is our emulator device, is a rooted device, we are able to do this, we are able to perform this. Okay, so let's check it out. So I'm gonna be opening up the messaging. So let's send a message to okay. So since we have sent out a message to a random number out here. Okay, so let's go back. So as what is mentioned in the exercises there, we're going to be getting into the slash data, and when we do an ls, which is a command to list in the Linux environment, we do an ls, we'll get to see different set of directories here listed. Okay, there is com.android.camera, com.android.calendar. So these are the resource folders for different set of applications. Okay, so things like com.android.musicfx is for probably the music application, com.android.phone is for the phone application, and bunch of other things. Okay, so for us, what we need is com.android.providers.telephony. Okay, so since this is the application that's currently handling the SMS part, let's cd into it. Let's get into this. I do an ls again. We see there are three different ways in which the data is being stored. One is the database, another is the library, another is the shared preferences. Okay, but for now we will be only looking into the databases. Let's go ahead and look into the database. So we do a cd space database. When we do an ls, we get to see two database files, and there is database journal. Okay, so the thing that is of really a good interest for us is the mmsSMS.db. Okay, so we could go ahead and sort of use the SQLite 3 option here and sort of see what's in that particular database, or we could use something called as SQLite browser. Okay, that's an application that you could download for your host machine, which is either your Windows, Linux, or Mac, and then go ahead and use that to sort of extract things from the database file. Okay, so we're gonna be opening up another tab here where we're going to be pulling out that particular file. Okay, so since it is in the slash data slash com.android.providers.telephony slash databases, let's pull this uh, you know folder out onto our desktop. Okay, let me get onto my desktop. I do this. Okay, so I'm going to be doing adb space pull space. Okay, so it says that uh, files have been pulled out, 8.3 mbps per second, 8.3 MB per second. Okay, all that is shown there. Okay, so now let's get back to our desktop. Go here, open this up. We open up the databases. We have this. So we have DB browser for SQLite. Let's open this application. We go ahead and click on the open database. In that desktop, Spangler databases mmsSMS.db. Okay, so you get to see the structure of this particular database, or all the different tables, the columns, and all of that. So we are mainly looking into the SMS part of it. Okay, so what we are going to be doing is browse the data, click on browse data, go to the SMS part. Okay, if we go here, so it says, hey OWASP Bangalore, how are you? So this is the body of the message. Okay, so which means that basically our SMSs are getting stored in the database of this particular application. Okay, so that's about it. Okay, so this exercise that we did was mainly to show that what how it is when the phone gets rooted, how it is easy to access any particular resources of any application. Okay, in a normal scenario this isn't possible. Okay, so let me show you another example. So let's say I switch this off, I turn this on. Okay, so let me go to settings and I go to security. So currently there's no screen lock. Let's put a pattern here. Let this be our pattern. I'm going to confirm this. I go back, I switch off and I switch on. I try giving any random pattern, it shouldn't open. I give the correct pattern, it opens up. Okay, this is a fair normal way of how the pattern lock really works. Okay, so now I've switched on. Okay, and this is a rooted device, as we all know. What I'm going to be doing is, since I've already got adb shell into this, okay, so there we now slash data cd space slash. So I do an ls here to list. What I'm going to be doing is I'm going to be getting into cd space data, then I do an ls, and we'll be getting into cd space system. Okay, I'm going to clear this, do an ls. So in this directory, we get to see a lot of different files that are being present here. Okay, that are specific to the system. And when I say system, it's this Android device. So there's also this file called as gesture.key. Okay, so this gesture.key file holds the pattern for your pattern lock. Okay, so as a hacker, the first thing that would come to my mind is what will happen if I sort of meddle around or do something to this gesture.key file. Let's go ahead and give it a shot and see what happens. So I'm going to be doing rm space gesture.key and click on enter. And when I do this, you remember the pattern, right? It was L. Okay, it went like this and this. Now I'm not going to use that pattern. I'm just going to click on this and the phone gets unlocked. Okay, so this is something that usually you're prone to when you root your device. Okay, so these directories are not really accessible when your phone is unrooted. Okay, so that's something that I just wanted to show you guys. Okay, so let's clear this. Let's clear this part now. Let's go back. Let's get back to our presentation. uh, there's our presentation here. Okay, then next we have is the secure IPC. Okay, so the inter-process communication between the application is something that is of prime importance, because let's say there is an application that the way these applications communicate is also kind of very important. So that's again dependent on a lot of application components such as content providers, intents, services, and binders. We'll look into the secure IPC communication in a couple of minutes. Okay, so the Android permissions, as we had discussed earlier. So things about Android permission is that the application defines the permission, but it is completely left to the user to grant the permissions. So which means that the Android permissions are application defined but user granted. Okay, so permissions. So the Android manifest.xml file will have all the details that are specific to the Android permissions. Okay, like what are all the different set of permissions that a particular application is asking, and all other details about that particular application. Okay, uh, then so as we spoke about this in the earlier slides, that the user will be prompted to either accept or deny the permission before the installation of the application. Okay, so earlier in the older versions of Android, we could only accept all or deny all the permissions, but with the recent versions, you have the user has the option to allow a specific permission or deny a specific permission. Okay, so let's see if there is an exercise for this. Okay, so this exercise is mainly to look at the Android manifest.xml file of a particular application. So the more about what this file is and all of that, we'll be actually looking into it when we reverse engineer the application. I know there will be a lot of confusion at this point of time, wherein you would be thinking like, where did this file suddenly come up from? Android manifest file, Android manifest.xml file is an XML file that is present in every single Android application that gives a lot of information about that particular application. Things such as what are all the different set of activities or what are different set of screens that an application would have, what are all the different permissions that the application is asking, and bunch of different data about that particular application. Okay, so let's go ahead and try this exercise out. So we'll be using this tool called manifestviewer.apk. I hope I have it on my device here. Hmm, manifest viewer. Okay, I guess it's not here. Let's go ahead and download this and see. Manifest viewer. Yes. So this is the one. Let's install this. Yes. So if you just looked at it, it showed like what kind of permission that the application was asking. Okay, so we open this up. Okay, so what was it written in the exercise? Okay, navigate to the resources folder. Okay, so we are going to be installing this. Okay, so we have basically installed it not externally but using the Play Store. That's fine. We can go ahead and install some other application using adb command. Okay, so for now let's go ahead and see what are the different set of things that we get to see here. So let's say we take some application. Let's say we are using Android live papers. Okay, look the Android manifest. Okay, so this is the Android manifest file. So it has an XML. It is an XML file, by the way. Okay, if you closely look at this, okay, so it basically has you know different data, such as the different activities that are currently there, the different intent filters, different sort of application components. So the more on application components and all of that in bunch of in a couple of minutes, we'll look into that in much bigger detail. Okay, so yeah, do we get to see the permissions here somewhere? Yeah, if you can see Android permission dot bind wallpaper, that's one of the permission that is being asked for. Let's try and see if we have any other application where we can look at. Hmm, okay, so we have Chrome here. So in the Chrome, let's look at the Android manifest.xml. The unknown attribute was okay. That's fine. Use permission. Yeah, you have request install packages, reorder tasks, read contacts, Bluetooth admin, access network state, access Wi-Fi state, access find location, access course location. Okay, so these are a bunch of different sort of permissions that the application is currently asking us. Okay, so we could look into this manifest file.xml in a couple of minutes in a much more detailed way. Okay, so I mean, just wanted to sort of show you guys, like, how we could be able to determine the different set of application. Okay, so let's go ahead. Mm, let's go back, and here we see. Okay, so let's go back to our presentation itself. Okay, so these were the different set of references that I made use of. I'm really sorry for the background disturbances if you're able to hear some noises from the background. Uh, I think probably I'm having a bad neighbor. That's okay. So let's get to the applications and boxing. Okay, so sandboxing, as we discussed, applications from unknown sources are usually are isolated to prevent malware attacks. Okay, so the one of the primary goal of sandboxing is to achieve security. Okay, so based on the application's UID memory space is allocated to the applications, and it's very restricted access to the resources is given to these applications. Okay, so applications have hardly access to the kernel memory, and at installation, every app gets an own Linux user assigned. So I hope you guys remember that we spoke about this in bunch of in couple of minutes, just couple of minutes back, where I was able to show you with the PS command. You get to see different set of users that are currently there on that particular Android device. The user ID or the username given as something like this. Okay, so every app gets a directory within the file system, which is /data/data com dot example dot app or com dot something. It depends on how the naming convention is being made for that application, but usually all these application specific data resides in /data/data. Okay, so setting up the mobile pen test environment. uh, so there are a bunch of tools that we'll be using. So one thing is the Android SDK, or the Android Studio would also come in with all that things that are needed. If you could be able to install the Android Studio, that would certainly help. Then for the test device, we could go ahead with using Android Virtual Device for the emulator part, or we could use Genymotion emulator, which I'm using at this point of time currently, and or we could go on and use an actual Android real device. But make sure that your Android is the USB debugging is enabled on your Android device, and you have root permissions. That's one of the primary needs. Then we'll be also having ADB installed on your host machine. Then for if you want like a complete suite of all the applications put into one single distro, I would suggest you to go with either Santoco Linux, or there is an application that's called Appy, and another homegrown Indian uh, you know uh, distro called Android Tamer. That basically comes in with all your set of tools that you need for Android pen testing or Android security. Okay, so we'll go ahead. Setting up the Genymotion, it's fairly simple. It's just a normal installation that you would want to do. So you could go on and download the latest version of the virtual box, or you could directly go to genymotion.com and download the Genymotion as well as the virtual box. Okay, so that's one thing. Then Android application architecture. So okay, so here before this, this is one of the primary things that we need. Apart from that, most of the tools are easily downloadable and installable. Nothing much to worry about. As we go on, you will see that there are hardly 4 to 5 different sort of applications that you would require to sort of reverse engineer an application, and to see and to sort of even analyze that particular application. So consider the Android application architecture. Okay, so the APK architecture goes like this. So first you have is the Java code. Then using the Java compiler, you basically that gets converted to a .class file. Okay, then there are a bunch of other bytecode or other class files with which you have your Dalvik executable ready, which is your classes.dex file. Okay, and with your Android manifest.xml file and bunch of other set of resources combined together, makes your Android APK file finally. Okay, so these different set of files combined together makes your Android APK file. Classes.dex, Android manifest.xml, and all your resources, that includes even your certificate files. Okay, so we'll look into the certificate files as well in a couple of minutes. So let's get started with the reverse engineering. Okay, so what are all the different set of tools that we'll be needing when we want to perform reverse engineering on the on your Android application. Okay, so the tools required are these are quite very simple tools that you would need. Things like dex to jar or JD-GUI or apktool. Okay, so these are fairly easy downloadable and installable applications, tools, downloadable and installable tools on for your host machine and your actual Android application that you want to be reversed. Okay, so these are the 4 major components that you would require. Okay, so let's look into the APK tool, what it does and why do we use it. It's an open source tool built for reversing the Android APK files. Okay, so couple of prerequisites: Java 1.7 or higher version of that. The syntax basically goes like this. Uh, you know you will get to see the syntax when I do the demo itself. Okay, so there are a bunch of different flags that we could use for the APK tool. D is specifies the tool to decode the APK, and minus S to, helps prevent the disassembly of the dex files and keeps the classes.dex file in the output folder. So these are a bunch of different flags that we'll get to see when we sort of run the APK tool on our application. Okay, so the resulting output will be a directory with the same name as the file name of your APK. Okay, so during the decoding process, many of the essential files, including images, layouts, strings, and XMLs, are brought back into their original aspects. Okay, so now the reason why we use APK tool is to extract all these, the resource components and see, what information we get out of them. Okay, it mainly helps us. It helps us in make the Android.xml file easily readable. Okay, so before that, I think I can be able to sort of show you guys how we could also decompile an application. Okay, so I'm gonna create a new folder called test here. I'm gonna just copy this, put it right here. So I could go ahead and rename this .apk file to .zip file and use the zip, and then go ahead and I could extract this. Okay, my bad. So this is being extracted. Okay, so we get the extracted resource folder here. Okay, so this is your android manifest.xml file. Okay, then you have your classes.dex file. You have a bunch of other different files and folders. We'll get to look into that in in a couple of minutes. So we already have our android manifest.xml file. So now you would be thinking that why do we even need apk tool? You've already decompiled the application. Okay, but let's go ahead and open this xml file using our sublime text. You will see that the Android manifest.xml file is totally different from what we had seen earlier, right? You're not able to understand a single thing over here, right? It means that we are not able to decompile the application in a better way. Okay, so that's one of the primary reasons why we still go ahead with using tools like apk tool. Okay, so let's delete this and let's rename it back. .apk. I'm gonna use the apk thing. Now we come out of this. So currently we are, where am I? Okay. Okay, so we'll get into the test folder. We have this. We're gonna run apk tool space d space diva beta.apk. Let's run this. So you'll get to see loading resource tables, decoding android manifest.xml with resource. So that's one of the primary things, right? So in previously when it decoded, it was a different thing when we manually decoded it. Now since this tool is being able to decode it in a proper way, we'll probably get to see the actual android manifest.xml file. Okay, so once this whole reversing is done, let's look into that folder. So there's a folder that got created. We open this with sublime text. Open this. Okay, awesome. So we get to see the actual XML file here. Okay, so here we get to see different activities that are there. What are the different permissions that the application is asking? Okay, so these are the permissions. These are a bunch of different activities. So activities are nothing but your screens of in the mobile application. So you get to see like login screen, there is a dashboard screen and all of that. All these are basically different set of different activities. Let's go back. Okay, so we're done with this apk tool. So it was fairly easy, right, to sort of decompile the apk using the apk tool. So let's go ahead and see what we could do with the dex to jar file. Okay, so dex to jar file basically either converts classes.dex files into jar files, but with the recent upgradation it also converts your .apk file to jar files directly. Okay, so yeah, so as I just mentioned, the dex to jar tool is an open source tool for working with .dex and .class files. We would be using this tool to convert the apk files to jar files directly using the instance. Okay, so this is how the command basically works. d2j-dex2jar.sh because it's a shell file. If you're running on your Windows machine, then it's going to be .bat file. You get everything in that dex2jar folder itself when you download it. Okay, and then you give the file path of for your dex file or your apk file. Then if you want to specifically give a particular name to your jar file, or you want to specifically put it in a particular folder or a directory, then you give -o option and give the actual output file name .jar. Okay, so we'll do this. Let's get started. Mm, we'll get back to our test. We'll delete this. Currently we don't need that. Map a terminal. So we put it right here. Okay, so okay, so we have this. So I'm going to be using d2j hyphen dex to jar. Okay, so this will, when I run that, it's going to give me a bunch of different flags that I can use. Okay, so in the similar way, the previous tool also, when we ran, if I just type in apktool, it's going to be giving me different set of flags that I can use. Every single flag is for a different reason. Okay, so considering that, let's go back. d2j hyphen dex to jar space. So here's the thing. So we could either give the diva-beta.apk file, or remember when we decompiled the application using apk tool, we got something called classes.dex file. So we could either give that, or we could directly give the apk file. Since we are lazy, let's give the diva-beta.apk file itself. Okay, so I'm going to click enter. I'm not being very choosy or picky about where I want my output file to be. So I'm just going to give these two things in the command. So let's wait until this cursor is done. Okay, so it's already done here. So we have our jar file that that has got created here. Let's see what needs to be done next. Next, we are going to be running this tool called JD-GUI. Okay, so JD-GUI is basically used to view the decompiled .jar files and allows us to sort of browse through the source code of the .class files contained in that particular .jar file. Okay, so let's look into that. Okay, so installing this isn't a big deal. It's fairly easy. You get a lot of you do get a lot of resources on how to install it and all of that. Okay, so let's get to the desktop. I'm gonna do JD-GUI. Okay, so this test, I'm gonna drag and drop it into this. Fairly easy. If I do this, I get to see the until up till the source code level, right? So this is really interesting, something really interesting for people who wanted to learn how to sort of decompile an Android application. Okay, so just a quick look back on what we did. Okay, so we basically used three different tools. One was apk tool, one was dex to jar, and another one was JD-GUI. Okay, apk tool was basically to again was to decompile the apk file in such a way that we could be able to sort of read the Android manifest.xml file much easily, and also to get a hold of bunch of other files like resources or certificate files, and and all of those classes.dex files and all of them. So once that was done, we also went ahead and used dex to jar to basically go ahead and uh, you know again decompile the either the classes or apk file and into jar file, and basically use JD-GUI to get all the source code part of it. Okay, of that application. So now that we are getting the source code of this particular application. Okay, so I think I just forgot to mention that the application that we are currently using is the Diva, which is damn insecure vulnerable Android application. So you could get this is an application that's primarily used to sort of learn Android security. If you're interested in learning Android security, since you're here, yeah, that's one of your primary reasons. I would really suggest you to check out Diva Beta. Okay, so there is uh, divabeta.apk, and do a GitHub on this. Okay, so you will get to see the GitHub uh, page for this. Okay, what it does, what are all the different set of vulnerabilities that are included in the Diva application. So insecure logging is one of them, hard coding issues, insecure data storage, input validation, access control issues, again hard coding issues, and bunch of other input validation issues and all of that. So if you over the course of time, if you would want to contribute, you could surely go ahead and do that, and bunch of other details about this. Okay, so yeah, so let's get back to our presentation. Okay, here's the presentation. So there's one more thing that we need to be doing, which is to understand the certificate files. Okay, so when I say certificate files, every Android application usually gets signed by the developer who has developed that application, or the organization where the application gets developed. Okay, so let's go ahead and sort of look into that. Okay, so we go back. So for this, we need to get access to the meta-inf /cert.rsa file. Okay, we'll do that. We'll close this. We'll, since we have Diva Beta APK, we'll open up the terminal. So I'm going to be using apktool to reverse the APK. Okay, so this is done. We get into the Diva-beta, and we'll get into the original. Inside this folder, you will see something called meta-inf folder. You open this up. You see three different files. Okay, cert.sf, manifest.mf, and cert.rsa. Okay, when you open up cert.sf or manifest.mf, the contents of these two files are same. Okay, henceforth, if you also look at the size of these files are also pretty same. Okay, so let's open this up with a basic text editor. You will get to see that there is an SHA digest for all the resources of that particular application. Okay, if you just go by, you will see that these are different set of resources that are listed. Okay, so this is, okay, let's consider this is in the resource directory, and this is a resource which is a .png file, and this is the SHA1 digest for that particular file. Okay, so I know that this is what is the content of that particular file. So similarly, let's also open the manifest.mf. Even this is pretty much the same though. Okay, and this has got pretty much the same data as what cert.sf has got. But if you closely look at cert.rsa, let's try opening it with a text editor app. Okay, you will see that this data is completely in an encrypted form. Okay, so it is not readable by a normal text editor. For this, we'll be using a tool called keytool. Okay, to basically print the certificate of this particular application. Okay. Since we are in this folder now, meta-inf. Okay, so the cert.rsa is the file that was mentioned right in our presentation. Okay, so this is the command line for printing the certificate. Okay, let's go ahead and do this. So this is here. I'm gonna close this. Okay, so let's get into. I'm gonna go into the original meta-inf. Clear this part. I'm going to be using keytool. Okay, so this kind of gives me all different set of you know flags that this tool has got. I'm going to be using keytool space minus print cert space minus file space cert dot rsa. Okay, so when I do that, it's gonna give me a lot of information about that particular certificate. Okay, so it'll tell you the signature algorithm name, which is SHA-256 with RSA, the public key algorithm, and a bunch of other data as well, like who's the owner, the issuer, the serial number, valid from, until when, and all of that. Okay, so you get to see the complete certificate data about of this particular application. Okay, so it's kind of a very relevant information that we are getting out of this particular tool. So this was about understanding about the certificate part of it. Now let's go ahead and see what else we have. Okay, so this is pretty much on the explanation of what is a cert.sf would basically do. Okay, uh, as we already spoke, this could be easily opened up using a normal text editor like Notepad. Okay, so you would see contents of the cert.sf file. It generally which is used when the jar signer tool tries to verify the content of the application. Okay, it computes the cryptographic hash of the resources listed in the cert.sf file and compares it to the digest that are listed to each of the resources. Okay, so as we looked here, okay, so there was SHA digest for every single resource that was mentioned here. So the jar signer tool would basically go ahead and sort of verify them just to check, if there was any tampering that was made with the application or something as such. Okay, so the contents of the meta-inf directory. You know, it basically contains the manifest.mf and the cert.rsa and the cert.sf file. Okay, so the manifest.mf and the cert.sf files contain the pretty similar content. Then the cert.rsa, this is the public key certificate that we looked at. Okay, so this is about basically the meta-inf uh, folder. Okay, the cert.rsa, which is basically a X509 version 3 certificate. Okay, and the information in it is basically structured by the key tool in the following way. You get to see the owner of the public key, which is basically the organization associated to that individual. Then the issuer, who declares the issuer of the X509v3 certificate to the holder. Then the serial number, what is the serial that identification number for that particular certificate that is issued. Then the validity of that particular certificate, from when to when is it valid and all of that. Then the certificate fingerprints. Okay, so we need to remember that in this scenario there is no certificate authority. So the thing about Android application certificates are that they are self-signed certificates. Okay, so there is no concept of certificate authority that is prevalent in a bunch of other architectures, such as, let's say, if we consider TLS or the HTTPS, the certificate authority there are a bunch of organizations that sort of issue the certificates, but in this scenario it's a totally different game. The certificate is self-issued, that basically tells all these different set of information. So now let's get to the actual part of our presentation, which is the dynamic and static analysis of the application. Okay, so there are a lot of questions that get raised when we say what is a dynamic analysis or what is a static analysis and all of that. Let's look into this. So when we say static analysis, it basically involves the decompiling the application and looking at the source code and then trying to analyze it to understand what the application is doing, or if it's a malware, then what is the malware doing. Okay, so there are a bunch of tools that are used for static analysis. uh, One of them, a couple of them that we already used are like apktool, dex2jar, JD-GUI, and there are a bunch of other tools also that we could use. Mobile sandbox, IDA Pro, APK inspector, androgard, which is quite familiar, which is quite famous. There's something called JAD, and there is Dex Dump, Smalley, Quark, etc. There are a lot of tools that we could go ahead and utilize. Okay, so there's also another quite amazing tool called MobSF that you could sort of host it on your local machine and sort of run it and sort of get a complete static analysis done on your application. uh, so that's a really interesting tool. It also has got a dynamic analysis to it. That's also pretty interesting. That I'm sure you guys should be checking that out. A MobSF tool. So you could go on and Google and just type in MOBSF. That will sort of give you a link to their GitHub page, and from where you could get to see how to download it and install it and run your applications onto it and all of that. Okay, so example, let's decompile an apk, say diva beta.apk, using apk tool, and navigate to the extracted source code folder and try to analyze its Java classes and methods. Okay, so which I think we have already performed. Okay, which this static analysis of the given sample concludes the following: application source code is in raw format without any obfuscation, able to understand application flow. Okay, so I think this is something that we are looking at. Um okay, so since we are going to be opening it with the JD-GUI, so here are all the dot classes file. So one thing that we realize is all this code is easily readable. There is no mechanism called as code obfuscation that is being implemented. So code obfuscation is a mechanism that that is usually implemented in the production level applications, just to ensure that even when the application gets reversed, even when they get to the code level, you know uh, the code wouldn't make any sense to the person who's reading it. Okay, so that's one of the things that an obfuscator would do. So considering the Android scenario, two of the major obfuscators that are used are DexGuard and ProGuard. Okay, Dex as in DEX guard, and Pro as in ProGuard. Okay, so this would fairly give us the flow of how things work. What are all the different classes, what are their intentions, what do they intend to do. So here, if you can see hardcode to activity, you'll get to see, it is kind of giving a toast, says access granted, see you on the other side for some input text or something, and there's another toast that says access denied, see you in hell, or something like that. So it kind of fairly gives that, okay, this class is for this activity for hard coded passwords or hard coded data. And it's basically sort of giving a toast to the user, saying either the access is granted or access is denied. Okay, so we fairly get some good understanding of the application with this. Okay, so with that, let's move ahead with what we have here. Okay, so now coming to the dynamic analysis part of it. Okay, so the dynamic analysis compared to the static analysis is quite different. Okay, here you try to analyze the application while you're running it. So far whatever we have done considering today's exercises, wherein we use the apk tool or dex to jar or JD-GUI, we were able to analyze the application in a static manner. Okay, so from now on what we will be doing will be based on the dynamic analysis, which means while the application is already running, we would go on and perform different set of actions and try to see how the application is doing. Okay, so we could go on and use burp suite. Burp suite is quite very famous proxy tool for performing dynamic analysis. I mean, it is quite quite well known in the web application pen testing space. But let me tell you that this is also being used in the mobile application space as well. Okay, so the dynamic analysis part we'll be doing in a couple of minutes. Okay, so we'll be looking into the insecure data storage. When I say insecure data storage, there are a bunch of different ways the data is stored insecurely. Okay, so we'll look into that currently. I think let's get to the demo side. So now that we have completely sort of decompiled the Diva Beta APK, okay, so we have the backend code here. We know what class does what, okay. So these are different activities for which these are the classes, and let's actually run the application and see what could be done. Close this, minimize this, open up the actual comment. We have Diva. Then when we open up the Diva, you have these different set of vulnerabilities that are being listed here. Okay, so it's intentionally designed to be insecure. Okay, the aim of the app is to teach the developers and all others to sort of of the flaws that are currently present in the Android architecture. Okay, so Android application. Okay, so the first one is insecure logging. We'll look into that in couple of minutes. Then there is hard coding issues. Then there is insecure. There are mainly four different ways of insecure data storage that we can see here. Then there is input validation, access control issues, hard coding issues, and again input validation issues. So we can look into bunch of them, okay, if not all of them, but we'll get a fair understanding. But before we get on to see what these vulnerabilities are, basically, let's look into a bit of theory. Okay, when we say insecure data storage, okay, so the app usually stores sensitive data insecurely in considering the insecure data storage. Okay, so possibly either with an insecure file permission or with insecure encryption or encoding, making it accessible to unauthorized parties. Okay, so since we looked at the thing wherein if the phone is rooted, it is easily possible for us to get access to data that is present in /data/data directories or any application specific directories mainly, right? So let's go ahead and look see what are the different types of insecure data storage. So one would be the hard coding sensitive data in the application source code. When we say hard coding sensitive information, things maybe such as passwords or say API keys or some credentials or some really important critical information that is actually coded in the application, and let's say there is no obfuscation that's been put in place and all of that, then it's a cakewalk for the attacker to sort of get any information from the application. Okay, so that's one part of it. Then the next thing is sensitive data that is stored in the application sandbox. uh, uh, when I say application sandbox, that basically again brings us to /data/data/ that particular folder. And in the databases, just couple of minutes back, we were able to look at the the database folder and extract the database file out of it and see that our message was stored in that particular database, right? And let's say, for example, if there is an application that takes in users login data and saves that username and credential in just plain text locally on the device. Okay, so that's really insecure, completely insecure implementation. Then sensitive data that gets stored in the temp files, and also sensitive data that gets stored in the external storage. Okay, so these are a bunch of different types of insecure data storage that usually happens. Okay, moving ahead. So we have challenge one, which is insecure data storage. The goal is to find out the login credentials and enter it into the application to gain the access. So let's try and see what we could be able to do now. Okay, so insecure data storage, stored some. Okay, find out where or how the credentials are being stored and code. Okay, so insecure data storage part one. Let me type in my name. Let me give fairly insecure password. Okay, third-party credentials have been saved successfully. So here's one thing. So since we have access to the backend code, let's look in to see how these things are usually getting stored. Okay, so we are able to see something like this. Okay, so user is this, password as a string. Okay, third party credential saved successfully. You get a toast here and all of that. Okay, let's go ahead and see at the back end when we do our ADB. Let's do ADB space devices. We have our ADB device, we shell into it. Okay, so now here we have this file, which is the folder, which is jakhar.asim.diva. Let's get into that. Cd space dot, I do an ls. So there are two different temp files that are being stored, and there is also shared preferences. Let's look into the shared preferences and see what we get. There is, okay, we'll do a cat and see. Okay, so if we can see here, shared preferences is one of the mechanisms to uh, store things locally on the device. In that you basically store things in an XML format. Here, if you can see, the user and the password, which is Nikhil and QRT 103456, is being stored without any form of hashing or encryption, and it's completely insecure to store these things at such a location. Okay, so that's one of the insecure ways of storing data, which is in the shared preferences. Okay, so we're able to finally find out this. Let's move ahead and see another one, insecure data storage. Okay, so the goal here is the second challenge would be, the goal is to find out where the user entered data is being stored under application sandbox. Okay, let's go back. Insecure data storage part 2. Okay, let's give some other random name. Okay, so the credentials are stored now. Let's do Okay, so before that, we can sort of go ahead and look into the backend where we have our JD-GUI, just trying to see what how these things would be done. So if we look at insecure data storage to activity, we fairly get to see some SQL queries here. Create table if not exist, insert into my values and all of that, which kind of gives us an understanding that okay, so this is basically done at the database. Okay, so let's minimize this. Okay, and we get into the databases. We do an ls. Okay, so we have a lot of database files here. Okay, what we could also do is, since we have already done this before, I hope you guys remember this, we're going to be doing adb space pull space /data /jacker dot scene dot diva /databases. Okay, so have been pulled. Where are we at this point of time? Okay, so we are in a different folder altogether. Really sorry for that. I shouldn't have done it in this folder, of course. Sorry about that. Okay, so we have our IDS2 SQLi and there is diva nodes.db. So what we can do is use our tool, which is dbbrowser.sqlite. We can go ahead and open the database. Sorry, it's here. Let's open this up. IDS2. Okay, let's try browsing the data. There's something called my user. Okay, so again, if you could see here, the username and the password is being stored in the plain text, and this is quite easily gettable, right? So again, there's no hashing mechanism that's being used or something like that. So this is one of the insecure ways of storing the data. Okay, so yeah, so that's one that's another challenge that's done. Okay, so let's move ahead and look into challenge 3. So the goal is to find where the user entered data is being stored under SQLite database. Okay, so maybe I may be wrong here. I might have sort of interchanged the challenge 2 and challenge 1. But anyways, let's look into that. Okay, so let's look into our JD-GUI. So it says file.create temp file, uinfo temp, third party credentials saved successfully, and all of that. So it kind of fairly gives us an understanding that there is a temp file that is being created somewhere and that file is being stored. Okay, let's figure that out. Okay, if that's the case, for that we got to open up. Okay, so another random person. Save. Okay, so this is saved. I go back to this, do an ls. Okay, so now we see, okay, ls minus a. The one that was recently created seems to be this. Okay, we'll figure that out. Cat space Okay, this is a different password again. Let's try it with 152. Okay, so here we get to see another random person, another random password, which is the one that we recently entered. Okay, so yeah, so this again is a really wrong way of implementing it. Okay, so you get to see your username and password being stored in a temp file, which is again in an insecure way of implementing the data storage. Okay, so we'll go back to our presentation. Where is it? So the next challenge that we have is the insecure logging. The goal is to find out the user entered information that is being logged under logcat files. Okay, so logcat is something that's again very specific to ADB. Okay, we'll look into that. So insecure logging is the first one. It says enter our credit card number. Let's randomly give some number that I can enter. Okay, so for that I should be on my system. Remember, I'm running the ADB command, for which I need to be on my system and not in the device, which is I'm not supposed to be in the ADB shell. I need to be outside the ADB shell, which is my system basically. Okay, so I'm gonna be doing ADB space logcat. So then you get to see this log, and I do checkout. Okay, so if you look at this closely, my credit card data is getting logged. Okay, which shouldn't be happening whatsoever. Any credential or any critical information should never ever be logged in such a manner. Okay, that's one of the most insecure implementations. Okay, so that's one part. Now let's go ahead and look at a bunch of other things. So the insufficient cryptography is again a mechanism of using either the outdated or obsolete encryption mechanisms, or self-created encryption mechanisms, which could be easily broken. We have seen a lot in the past, a lot of organizations ended up creating their own encryption algorithms, and said they were secure enough and all of that, and ended up getting hacked. Also, another thing would be that no cryptographic implementation at all is also an insufficient cryptography vulnerability, wherein, as we saw, the in the application, the credentials such as passwords or usernames were being stored, especially the passwords were being stored without any sort of hashing mechanism that were supposed to be put on them. That was never being used. So yeah, so fairly this was like the demo part of it, the dynamic analysis demo that I wanted to give you guys, with respect to the Diva and different bunch of Android specific vulnerabilities. I hope you guys have gained some basic fundamental Android security learning from this presentation and from this video. I really thank you all, and some special thanks should go out to Mrs. Vandana Verma, who is the OWASP Bangalore lead, and Miss Asha Muniappa, who was one of my co-trainer at OWASP Seasides, Goa, and Mr. Naveen Belwadi, who is my who's one of my amazing mentors, and a really big thanks to the OWASP Bangalore team and the Null Bangalore team, who have always been supportive of upcoming researchers and security enthusiasts like me. All the time, they're always ready to help you guys out, if you want to learn something. And Yeah, I think finally, a big thanks to you. This was presented by me, Nikhil P. Kulkarni, and the presentations were made by my co-trainer, who was Asha Muniappa, for the OWASP Seasides. So I thank you all. I hope you guys have learned something significant from this presentation. In the future, I would surely be taking up some more ways to sort of some more advanced ways for considering the Android security as the topic. And I hope to see you guys some in any of the conferences. Just come and say probably a hi to me, if you ever get to see me anywhere in any of the conferences. So yeah, so that's about it. So I guess we could end this presentation here. I'm gonna stop sharing. Thanks a lot, guys. Thanks a lot for being there. Thank you very much.